But the huge molten core contributes something else essential for life on Earth. A way of helping to regulate the planet's temperature. It's a remarkable system. Magma, heated by the core, rises towards the Earth's surface. As it spreads sideways, the Earth's crust is very slowly dragged apart. This moves the continents, creating the Earth's restless and ever-changing surface.
The heart of the Earth, its inner core, is a solid ball of iron and nickel. Here the pressure is so high it never melts, despite the intense heat of 3,700 degrees Celsius. The outer core is under less pressure, so it is molten. This is enclosed by a deep layer of hot rocks called silicates. This is the mantle, and it's 3,000 kilometers thick. The surface is hard and forms a solid crust. If the Earth was a peach, this crust would be as thin as its skin. The Earth's crust is cracked and brittle, like an eggshell. It's made up of several segments called tectonic plates. There are two kinds of crust. Continental crust forms the great landmasses of the world. This is thick. These rocks are made of ancient lightweight substances like granite. Some were formed almost 4,000 million years ago. Oceanic crust, which lies under the planet's great oceans, is much thinner. Oceanic rocks like basalt are heavy and much younger, 1/20th the age of continental rock. The plates float on the dense mantle. Scientists believe that the immense energy of the Earth's inner heat sets up convection currents in these rocks, which move the crustal plates about, but very, very slowly. Some are moving apart. Some move towards each other. Other plates just slide past one another. These movements in our planet's crustal plates have created some of the most dramatic features of our world. In 1963, Icelandic fishermen spotted plumes of ash, steam and lava shooting out of the sea. Almost overnight, a new island emerged. Later, this would be named Surtsey. Lava poured out of the earth. The eruptions didn't stop until 4 years later. Within months, birds began to visit and plants grew. But what had happened? At the bottom of the ocean, two plates of continental crust had slowly moved apart. Molten rock called magma, lying below the plates, oozed up through the cracks. When it reached the surface, the magma cooled and solidified, forming lava. This gradually built up until it broke through the ocean surface to form an island. A ridge of lava and mountains has been formed where the two plates have moved apart. This runs down the middle of the Atlantic Ocean. The plates are moving very, very slowly, less than 5 centimeters a year. But over time, this has added up. Volcanoes like Merapi in Indonesia are caused by the collision of oceanic and continental plates, along what is known as a destructive margin. Over millions of years, heavier oceanic plate is being forced down under the lighter continental plate, creating a trench. Carrying water and debris with it, the oceanic plate breaks up under immense pressure. As it's forced down, it gets hotter and hotter, due to friction and because the temperature rises rapidly towards the Earth's center. Eventually it melts, and the molten magma rises to form volcanoes some distance from the trench. The Himalayas. This is the highest mountain range in the world, and it's getting higher all the time. Every year, Mount Everest grows by 1 centimeter. These mountains are caused by the collision of two plates of continental crust. They're called fold mountains because the layers of different rocks within the Earth's crust, the strata, are folded and bent. Over time, erosion of the layers can occur at different rates, producing characteristic jagged rock formations. The Himalayas mark the boundary between the Indian plate and the Eurasian plate. There, two sections of continental crust are moving towards each other. The world's major fold mountains, volcanoes, and earthquake zones all lie on or near the boundaries between the Earth's tectonic plates.
Scientists who sang, Alfred Wegener, you are a crazy man. Alfred Wegener, you are a crazy little man. They reminded him he had no proof for how or why the continents could do this. And until you show just how or why, you merely have one hypothesis. Until this evidence we see, you don't have a theory. Alfred Wegener, you are a crazy man. Alfred Wegener, you are a crazy little man. In the year of 1930, on an expedition to Greenland, Wegener got caught in a blizzard. When they finally found him, it was much too late, and they buried him in an icy mausoleum. 30 years after he died, a new idea came to light. It changed the way geologists saw the world and brought continental drift back to life. Now everybody sings, yeehaw! Alfred Wegener, you are a brilliant man. Yeehaw! Alfred Wegener, you are a brilliant, brilliant man.
Hai Gondwana. Garis katulistiwa memisahkan kita.